Telephone network management. So go ahead with the introduction. It starts with the vital for the seamless functioning of voice communication systems, supports PSTN, mobile, and VoIP networks. And you could see here, this is the general representation of the telephone network management. So the root going ahead with the network design and management and the supporting components and surrounding by the key functions. Like under the components, what we have is we have the switching systems, we have the transmission links, the signaling systems and the management systems. And the key functionalities includes the fault management, the configuration management, the performance management, and the corresponding accounting and billing management. And there are some management protocols and tools which supports this telephone network management. So the protocols includes the SNMP, the Simple Network Management Protocol, the SIPs, and the tools and the monitoring. And what is the trend which it leads to is it leads to the migration to this IP based networks. And coming ahead with the components of the telephone network management, there are some main important components considering the switching systems, the transmission links, the signaling systems, and the management systems. Uh, the switching systems includes there are some things the routing calls and via the exchanges, and the transmission links includes the connecting switches nodes. So the different connecting switches nodes comes under the transmission links, and the next one is the signaling systems. So there's SIPs and other stuff. What all which is included for the call management comes under the signaling systems, and this management systems includes this OSS and the BSS, the tools and other things for the operation. So this includes the components of the telephone network management system. And going ahead to the core functions, there are some core functions which plays a very vital role in this telephone network management. And what all the functionalities is the fault management, the configuration management, the performance management, the accounting and billing, and the security management. So these are the five important core functions. So going ahead with the fault management, what exactly the fault management does? It detects and resolves the issues. So that is a main purpose of fault management. So under the configuration management, what exactly it does? It performs the functionalities of device setup and also the maintenance. And under the performance management, it does the monitoring of the key performance indicators. The key performance indicators includes the jitter, the latencies, and other stuff. And the next coming into the accounting and billing. So going ahead into the accounting and billing, so there are some things which place some importance. That is what it does is the usage tracking with CDRs, and the security management, that is the fraud prevention and fraudulence and other stuff, and the data security. So all these stuff comes under the core functions. And the next is the what kind of a role in the network design. There are some very specific roles. The thing which fits are the scalability, the redundancy, the QoS, the quality of service, the interoperability, and the compliance. So go ahead with the scalability. What exactly happens in scalability? It accommodates user and traffic growth. So it generally sees how many users can be accommodated and also the type of a traffic growth. So all these things are managed under scalability. Next comes the redundancy. So what it does is, so speaking about redundancy, it ensures how system is reliable on performing these things. And next comes the QoS, a very important factor. So it deals with the voice clarity and the real-time performance. So that all comes under the QoS. Next comes the interoperability. What kind of what to say the root connection between the mobiles, the PSTNs, and the VoIPs. So it's like so these all things forms a big role in the network design. And the next comes the compliance. So it's like the legal interception, the kind of emergency support. So all these things forms a role in the network design. And The next part coming into this are the tools and the protocols. So what kind of the tools and the protocols which are can be utilized as another protocols? The simple network management protocol, the SIPs, the RTPs are the things which comes under that, and the tools which supports this kind of a system is the Cisco Call Manager, the Asterisk, the Wireshark stuff, and the Nagios. So all this forms the tools and the protocols. And speaking about the emerging trends, so the emerging trends definitely we are migrating from VoIP and LTE, the Voice over the Internet Protocol, and LTE, and also the cloud-based PBX systems, and the software-defined networks slash NFV for the dynamic control, and the AML for proactive monitoring. So all these forms the emerging trends, and the example which can be given is the thing of a VoIP network management. That is the SIP signaling, the RTP media path monitoring, the codec and bandwidth optimization, this load balancing, and call admission, and this real-time analytics and troubleshooting whenever there is a problem. So all these things can be classified under this VoIP network management. And coming ahead into this conclusion, so what outcome we really get from it? It ensures a reliable, high quality. It's a high quality communication. That is one big reliability it promises. And also the modern networks. Going ahead into the modern networks, what it requires is intelligent and kind of automated management. So this is one thing which forms a part. And the next thing we are going to see is about the distributed computing environment. So going ahead with a small bit of introduction, it's like these are when you bring multiple computers. Okay, when you're bringing in multiple computers, what it happens is it collaborates over a network. Okay, so it's like the key things for what to say, which comes into the picture is it's the scalability, the reliability, and the resource sharing. So all these things forms the key importance and part of introduction. And when we move into the characteristics of the distributed computing, there are some characteristics which helps out. The first thing is the resource sharing. The second one is the transparency. The third one is the scalability. The fourth one is it's the fault tolerance, and the fifth one is the concurrency. So these are the big characteristics of distributed computing. So the first one, go ahead with the resource sharing. As we all know, it's like it allows access across network nodes, right? And the second one is transparency. It's a unified system appearance. So the system should be very transparent. The third one is scalability. It's the easy node addition. Whenever you want to add a new node or something, the scalability forms a very vital role. It's important. The fourth one is fault tolerance. It's a resilience to failure. So how it withstands the breakdowns. The fifth one is concurrency. So it's the parallel process. So all this forms the characteristics of the distributed computing. And when you come into the components of a DC, so it's like there are some very important components, formerly the nodes. So if you're going to ask about the, if you're going to speak about the nodes, it's nothing but the clients and the servers. So the communication between the clients and the servers. The next one comes the network infrastructure, Mhm. The kind of communication protocols fixes inside this network infrastructure. The third one is a middleware, like the common service layers, like the core bus and RPCs comes into this. And the distributed applications is mainly into a multi-node software. That could be one big distributed application. And yes, what we can visualize is the distributed computing environment. As we said, it's a process between the client and the server. So it's like under the client, what we can make out is it has the, so it has the application, the client interface, the DC services, and the stub code. So under the server, it's the server interface, the server application, the DC services, and the stub codes. So thus, this client and the server is like how it is being integrated is through the RPC, the remote procedure call. So it's like so the what it actually does, whatever the client request, it's being accessed from the server. So the applications, the client interface, and the DC services on the server side, what they give out is the server interface, the server application, and the DC services. The advantages in this network design is like load balancing, yes, effective load balancing, efficiency through load balancing, the cost effectiveness with commodity hardware, and the flexibility in scaling resources. And also what it does is it supports geographically distributed operations. So all these things forms the big advantage in network design. And the next comes some management challenges. How what kind of management challenges it faces a management challenge with kind of security, and the next one is complexity, the next one is latency, and the next one is consistency. So all these things forms the big management challenges. Under security, it's like the biggest thing comes is this protecting this communication and data. Yes, that's a big management challenge. And coming ahead with the complexity, the managing the various distributed systems, there'll be multiple distributed systems. And definitely, managing that is a big task. So there is a big kind of complexity. Next comes the latency, the network delay. Wherever the what to say, the kind of delay and other stuff comes down, the latency part. And the next one is the consistency, ensuring uniform data. The data transmission is pretty uniform. So these are could be some big management challenges. And the tools and technologies. So speaking about the tools and technologies, there are some protocols, there are some middlewares, the monitoring stuff, and the frameworks. So speaking about the protocols, the TCP/IP is kind of a thing which maps over here. The transmission control protocol, internet protocol, and also the hypertext transfer protocol, HTTPs. All these are the protocols which sits under the tools. Speaking about the middlewares, we have the middlewares like Corebas, Java, Ramai, and other stuff. And coming ahead into this monitoring, the monitoring we have the can be done through the Nagios, the Zabbix, and the Prometheus. And the frameworks, what generally can be used is the Hadoops and Apache and other stuff. Okay, all this forms the framework which are can be utilized. And there are some use cases which can be checked out, like AWS and Azure. So these are the use case cloud platforms, like can be literally visualized, checked out in cloud platforms. And also the distributed database, like kind of Cassandra's and MongoDBs. And we can just add it through IoT based network, and also this large scale scientific computing. So all these forms the use case. And coming ahead into the conclusion, it's like yes, where it is mainly used, it's for the modern network systems. Here it is mainly used, and also it combines the scalability, flexibility, and performance. And the third one is it requires robust management practices. Yes, so kind of a robust stuff is required. And yes, these are things. And now we are going ahead with the TCP/IP based networks. So the best example we just go ahead is the TCP/IP protocol suite. Okay, and the importance in designing and managing the modern networks, and it also ensures interoperability, scalability, and reliability. And into the introduction of the TCP/IP, it's like how does the foundation of communication on the internet, and also the standardized framework for internetworking. Internetworking is one big concept which works out over here. So these are the things which comes under the basic introduction to TCP/IP. And yes, you could see here a representation. So this representation tells how the TCP work. The sender, he just communicates with the initial application layer, the moment through the transmission, then through the internet and the network access through the cables. Okay, so it's like that. It is being connected, and it goes ahead to the receiver. So how the receiver will get through over the thing is, it's like through the network access layer. From there, it passes to the internet layer. From the internet layer, it passes to the transport layer and the application layer, and it finally goes out, reaches the receiver. So this is how the TCP/IP works literally to the sender and the receiver. And the TCP/IP is, as we all know, it's a four-layer model, right? So the four layers includes the application layer, the transport layer, the internet layer, and the network access layer. So under the application layer, what we have is we have the HTTPs, FTPs, the SMTPs, and other stuff, the protocols. And under the transport layer, we have the TCP and the UDP. Okay, that is what we have it under the transport. Under the internet layer, we have the IPs, the ICMP, and other stuff. Under the network access layer, what we have this, yes, the kind of Ethernets, the Wi-Fi's, and other stuff. So all this forms the four-layer models, and the key protocols in each layer. Yes, the key protocol, the protocol which supports much, which is important in each layer. And in the application layer, we have the HTTPs and the FTPs, the DNS, the SMTPs, and other stuff. In the transport layer, we have the TCP, the most reliable, and the UDP, the fast connectionless. In the internet layer, we have the IPv4 and the IPv6 and other stuff. And in the network access layer, it's like Ethernet and Wi-Fi. So these are the key protocols in each layer. And the role in network design, yeah, what kind of a role it predominantly plays? The scalability from LAN to internet, yes, that is one big kind of a role it works. And the interoperability across vendors and the flexibility across multiple physical media, yeah, how it provides the flexibility between multiple physical and efficient routing via IP addressing and routing protocols. Okay, so this could be the roles in the network design. And when it goes in the roles in the network management, the IP address planning between the internet protocol version 6, that is IP, sorry, within IPv4 and slash IPv6. Okay, so these are the two things the network role is planned. And the performance monitoring using SNMP, the flows and other stuff, and the security through firewalls. Okay, so the fault diagnosis is also how it is being done through the ping command and the trace route, and the configuration with the DHCP and the DNS. And coming ahead into the advantages and disadvantages, the advantages is open standard. Yes, this is one big advantage, scalable and robust routing. Whereas the disadvantage, yeah, definitely there are some IPv4 limitations, IPv4 limitations, and the complex management when it becomes a large networks. So all this forms the disadvantage, some things of disadvantage. And the applications, the applications is this is generally considered as the internet backbone, and it's an enterprise and campus network that can be utilized, and also it can be utilized for the cloud computing infrastructure. It can be utilized over there, and for the IoT communications. So all these stuff forms the TCP/IP based networks applications. And if you want to take a example of network, I mean a case study, we can just incorporate a WAN using a wide area network using TCP/IP, and this IPv6 integration with IPv4. Yeah, that's a very classic example of a case study. And the hybrid cloud on premises and the network monitoring and what kind of security tools. So all this can be taken as a case study example. And when we just see into the conclusion and future trends, it's the adoption of IPv6 for scalability. And the thing is, the big integration with IoTs and 5Gs. Yes, probably still we are just still moving ahead. We are moving ahead into the areas of 6G also. So this kind of future trend interaction integration is also widely possible, and enhanced security protocols. And also think what it can be done is the continued dominance in network design and management. So this could be the big conclusion on future trends. And yes, coming into the communication protocols and standards, there'll be some that can have overview of communication protocols, importance of standards, and the foundation of network design management. And introduction, it goes ahead with how it works and what are the examples. It could be TCP/IP, HTTP, and FTPs, all these stuff. And yes, we can just visualize how the transmission media reacts between the sender and the receiver. So you could see there is a kind of a transmission message between the protocols. And yes, what is being done is the message is generally transmitted between the sender and the receiver, and some certain rules are this networking standards. It's like it can be used in Ethernets and Wi-Fi's. That is IEEE 802.3 and IEEE 802.11. And when we speak about the types of the communication protocols, the network layer protocols, the transport layer protocols, the application layer protocols, and the network management protocols. So the network layer protocols, yes, for yes, we can go ahead with those IPs, Internet protocols, ICMPs, and the transport layer protocols. It can be the TCP, UDPs, and other stuff. So these and the application layer protocols include the HTTP, FTP, and the network management protocols, the SNMPs, and the NetFlow. And yes, going ahead with the OSA model, the Open System Interconnect. So and the protocols, yes, we all know what all the things which comes under this. It's the application, the presentation. These are the different layers: session, transport, network, data link, and physical. So under the application, we could see the HTTPs, FTPs, SMTPs, DNS, the presentations, SSL, TLS. Under the session, we have the NetBIOS, the transport TCP UDP, network is IP, data link is Ethernet, and physical is copper and fiber. So these are the different OSA models and protocols. Thank you.